A very good morning to all of you. Our discussions for today is going to focus on the applications of binomial series. The application of binomial series. Let's say we have equations 1 plus x bracket to 20 or power 20 and the binomial expansion if we able to expand by using the formula before. So let's say we are using this formula. So we will have 1 plus x power to 20 equals to 1 plus 20x plus 20 multiplied by 19 2 factorial x squared plus 20 multiplied 19 multiplied 18 by 3 factorial and x cubed and to the last term. So the last term will be x power to the 20. So let's say x is equals to 0.01. So for example, we have a 1.01 bracket powers to 20. So this will be equals to 1 plus 20 multiply 0.01 plus 20 bracket 19 2 factorial 0.01 square plus 20 19 18 divided by 3 factorial 0.01 cube then plus to the last term which is 0.01 power to the 20. So usually we will take up to 3 significant figures or it's better to take up to 3 decimal places. Okay, so in this case, let's say continue doing. So we will have 1 plus 0.2 plus 0.019 plus 0.00114 plus 0.004 and then plus the last term which is 10 powers to the negative 40. So because we only need to consider 3 significant figures or it's better to the 3 decimal places so we can get the answer by 1.220. So this is our answer. So in general, for any positive integer, n, so 1 plus x to the power of n will be equals to 1 plus n x plus n times n minus 1 over 2 factorial x squared and then to the last term. So this is the general form for any positive integers. There's a two condition for this. First one, the value of x. So the value of x must be very small. The smaller x is, the fewer are the terms needed to obtain a good approximations. Actually, we are doing approximations. So in order to get a correct very close approximation, usually we need a value x with a smaller value. The smaller value, the better. Second, the accuracy required usually we take three significant figures and answer to three significant figures. Okay. Sometimes we may take up to six significant figures. Okay, let's say for example, um, let's say we have a 1 minus x power to the 7. So by formula we have 1 minus 7x plus 7 times 6 over 2 factorial x squared and plus the last term. Okay, let's say we have a let's say we are looking for 1.998 1.998 to the power of 7. Now because the 0.998 is too big, so we have to substitute by using 2 to minus 0.002 power to the 7. Then we factor by 2 to the power 7. So we will get 1 minus 0.001. So from here we will start doing um, this part. So this could be equals to 1 minus 7 times 0, 0, 1 plus 7 times 6, 2 factorial, 0.001 square plus, oh, here is a minus because minus x minus 0.001. So minus 7 times 6 times 5 divided by 3 factorial 0.001 cube, and then to the last term minus power to the 7. So this is equals to 2 to the power 7, 1 minus 0.007 plus 0.00021 minus 0.0000035. So equals to, because we only consider 6 significant figures, so this could be equals to 128 times 1 minus 0.007 plus 0.00001. So the answer is 127.107. So we have a few condition here. Please take note. The first one, the expansion is only valid for 1 plus x to the power n, and not for a plus x to the power of n. Second, the expansion is valid for a restricted range. So we need to define a range, or we need to tell what is the range for the value to be valid. Of the variable and the range must always be stated. Third, when n equals to -1, so we can have two general formula, 1 plus x power -1. So this could be 1 minus x plus x squared minus x cubed and to the n terms. Okay, 1 minus x power to the -1. This could be equals to 1 plus x squared plus x cubed plus r. So this condition is r must be the x must be between 1 and negative 1. Okay, take for example, we want to expand 2 minus x power negative 2 as a series of ascending power of x up to and including the terms containing x cubed. So the first step, 2 minus x power to negative 2 equals to 2 power to negative 2, 1 minus x over 2 power to negative 2. So this is equals to 2 to the power of negative 2. So here we can apply the formula 1 plus negative 2 negative x over 2 plus negative 2 negative 3 by 2 factorials negative x over 2 square plus negative 2 negative 3 negative 4 over 3 factorials negative x over 2 cube. Then we have 2 negative 2 1 plus x plus 3x squared over 4 3x squared over 4 plus x cubed over 2. So eventually we will have the 1 over 4 x over 4 plus 3x squared over 16 plus x cubed over 8. So if we want to consider the range for x, it could be negative 1, negative x over 2, and 1. So this is actually equals to 2 between negative 2 and 2. So this is the range. Another example, we try to expand 5 over 1 plus 3x 1 minus 2x as a series of ascending power of x giving the first four terms and the range of x for the binomial expansions to be valid. So first step, 5 over 1 plus 3x 1 minus 2x is equals to 5. So for this part, we must do it in a partial fraction. So we have to look for the partial fractions. So after solving the partial fraction, we will have 3 over 1 plus 3x plus 2 over 1 minus 2x. So we have two parts. The first part, 3 times 1 plus 3x power to negative 1, and the second part, 1 plus 1 minus 2x power to negative 1. So we will solve part by part. Okay, the first part. So we will start by solving the first part. 3 times 1 plus 3x power to the negative 1. So we know that the formula is 1 plus x power to negative 1 equals to 1 minus x plus x squared minus x cubed, and so on. So 3 times 1 plus 3x negative 1 is actually equals to 3 times 1 minus 3x plus 3x squared minus 3x cubed. So we will have 3 minus 9x plus 27x squared minus 81x cubed. So this is the first part. For the second part, 2 times 1 minus 2x negative 1 equals to so by formula we have 1 plus 2x plus 2x squared plus 2x cubed and to the last term. So we will have 2 plus 4x plus 8x squared plus 16x cubed to the last term. So by combining both parts, so we will have, eventually we will have 3 3 over 1 plus 3x plus 2 over 1 minus 2x is actually equals to 5 minus 5x plus 35x squared minus 65x cubed. So what is the range for x? For the first part, the range for x is between 1 over 3 and negative 1 over 3. For the first part, the range is between negative 1 over 2 and 1 over 2. So by combining both sides, so the final range for x will be between negative 1 over 3 and 1 over 3.